space is vast, dark, and silent. There are no road signs, no GPS towers, no up or down. So how do spacecraft know where they are, and how to get where they're going? In this episode of AstroTechUniverse, we're diving into the brilliant science of deep space navigation. From inertial guidance to celestial positioning, from Earth-based tracking to cutting-edge AI, we'll explore every method that lets a human-made object travel billions of kilometers and still reach its target. Why deep space navigation is so challenging. First, the scale. The distance from Earth to Mars is around 225 million kilometers, and that's close in cosmic terms. A spacecraft can't afford even a minor course error, or it will miss its destination entirely. Unlike on Earth, there's no friction to slow down or turn. Every movement is precise, every correction calculated. Inertial navigation systems spacecraft often use inertial navigation systems, INS, to track their own movement. INS relies on gyroscopes and accelerometers to detect changes in speed and orientation. These systems don't depend on outside signals. Once launched, the spacecraft knows how fast it's going and in what direction, kind of like feeling how fast you're moving in a car with your eyes closed. The challenge is that small errors can build up over time, so INS must be combined with other systems. Star trackers and celestial navigation. One of the most elegant solutions comes from ancient seafaring, celestial navigation. Modern spacecraft use star trackers, sensitive cameras that compare star patterns in the sky to a built-in map. This helps the spacecraft determine its orientation, its attitude, in space. By locking onto known stars, the craft can maintain proper alignment for communication, propulsion, or scientific instruments. Earth-based tracking and the Deep Space Network. On Earth, a trio of massive antenna facilities form NASA's Deep Space Network, DSN. Located in California, Spain, and Australia, these stations constantly communicate with distant spacecraft. By measuring the time delay of radio signals and using Doppler shift, scientists can calculate a spacecraft's velocity and distance with remarkable precision. This method has guided spacecraft like Voyager, Cassini, and Juno across billions of kilometers. Optical navigation and landmarks. When approaching planets or moons, spacecraft can use optical navigation. Cameras on board take pictures of celestial bodies and compare them to stored maps or models. This method helps fine-tune approach trajectories. It was crucial for missions like New Horizons to Pluto and OSIRIS-REx to asteroid Bennu. The spacecraft literally sees its destination and adjusts accordingly. Gravity assists and precise timing. Many deep space missions use gravity assists, flying by planets to steal momentum and change direction. To pull off a successful slingshot maneuver, timing must be perfect. Mission planners simulate years in advance to find alignment windows, and navigation systems guide the craft within kilometers of target points, moving through space at tens of thousands of kilometers per hour. Autonomous navigation and AI. As missions move farther from Earth, communication delays increase. A signal to Mars takes around 20 minutes round trip. That's why some spacecraft now use autonomous navigation systems, allowing them to make real-time decisions without waiting for instructions. AI-based systems on board future missions like the Europa Clipper or Mars Sample Return may even detect hazards and plot new paths on their own. The future of deep space navigation. What's next? Researchers are exploring pulsar navigation, which uses the rhythmic X-ray pulses of neutron stars like cosmic lighthouses. Others are developing quantum gyroscopes, which could reduce drift in INS systems to near zero. If we ever send probes to other star systems, these advanced methods will be essential, guiding craft where human eyes have never looked before. Deep space navigation is a triumph of physics, math, and human ingenuity. From ancient star charts to autonomous AI, we've found ways to explore the void and hit targets billions of kilometers away. Thanks for watching AstroTechUniverse. If you enjoyed this journey, subscribe, like, and comment below. What destination should we chart next in the cosmos?